McCormack.
Good afternoon and welcome to this month's show. I'm Luke McCormack. During today's show, we will discuss how the explosion of big data is being addressed in government programs. With me on today's show are Ed Kearns, Chief Data Officer, Noaa; Jeff Seaton, Deputy Chief Information Officer, NASA; Andy Brooks, Chief Data Science, National Geospatial-Intelligence Agency; Tom Sasala, Director, Army Architecture Integration Center and Chief Data Officer, U.S. Army; Henry Sowell, Chief Information Security Officer and Technical Director, Hortonworks Federal; Alan Ford, Director of Government Systems, Teradata; David Turner, President and CEO, Hitachi, Vantara Federal. Well, what a big subject we have, big data. And, I see this as this constellation of activities that are going on, right? We have all this input from IoTs, input from streaming data, input from imagery, and it's increasing and increasing and increasing. We now have this tectonic shift in processing that we can put together in regards to processing all this data that we're collecting. And we have this advent of products that are being developed to analyze all this data and doing that at scale now. I heard somebody say the other day the cost of curiosity is going down in regards to being able to get access and process this data. And the advent of data scientists are going up, right? So let's get right into it and let's talk about examples. I'm going to start with you, Ed, in regards to give us an example of where you're making some progress in regards to big data initiatives at Noaa. I'm sure you've got a lot of them.
Yeah, and we have a lot of data. So we've got, at any given time, we've got about 200 petabytes of data that we're working with on our data stores. We've got about 30 petabytes in our archive, and so we use it for our mission, for the American people, get products and services out. But there's also a need by industry and researchers outside of Noaa to get access to our data too. So one of the things we started about 3 years ago was something we call the Noaa Big Data Project. And this is something we've signed cooperative research and development agreements with Amazon, Google, IBM, Microsoft, and a nonprofit called the Open Commons Consortium out of the University of Chicago. And we've had a lot of success with this program where we're moving Noaa data sets, we're publishing Noaa data sets from within the federal government into their systems. And then these partners are then making these data available free and open at no charge to the American taxpayer so they can use these products to create new services, new products, whatever they want to do, new insights into our environment.
Wow, and that would be all things data, all kinds of weather data and the whole bit, right?
Right, and so we've got about 40 different data sets that we've moved into this partnership already.
Fascinating. Okay, Jeff, how about at NASA? Tell us about what's going on over there at NASA in regards to big data.
Also generating a lot of data all the time. Just one of our mission areas in our Earth Science area, we're generating more than 4 terabytes of data every day. So that's turning into results within the agency, but also data that can be accessible by the public and those outside of NASA. In terms of internal operations, you mentioned Internet of Things, and one of the things we're taking a look at is how can we leverage big data to more effectively operate our facilities. So we're instrumenting some of our key physical assets and being able to change the paradigm from a reactive model of maintenance, like when you change your oil filter in your car every 3 months. Well, what if it doesn't need to be changed? So we can now do predictive and proactive monitoring of our facilities and only go out and address issues when we see the data tell us that. And then we can develop predictive models that can help us in the future. So we're really operating our NASA facilities more efficiently more and more today. And that's a great example of savings for us as well.
Predictive analysis through this data analytics, that's interesting.
Yep.
Alan, how about at Teradata? What do you see out there in regards to progress that's being made across the community with the agencies that you guys are working with?
Well, Luke, I'd like to cite an example of the convergence of big data with another major industry trend, and that's cloud computing. One of our customers, the U.S. Air Force, engages in data-driven fleet management at VISCOS. That's the acronym for the 441st Vehicle Support Chains Operations Squadron. VISCOS uses sensor data in conjunction with a Teradata data warehouse to manage a $7 billion fleet of 80,000 different specialty vehicles at bases around the world. Data from all these vehicles are captured at every refueling stop and transferred to the data warehouse, where it's combined with more than 200 other data feeds, and they perform advanced analytics like repair versus retire modeling, buy versus lease calculations, condition-based maintenance, end-of-life projections, fleet health and readiness, and even what-if scenarios for funding adjustments. Cloud computing comes into play with the military's lift and shift program, which is engaged in moving the data warehouse operation from on-premises into the cloud. Air Force is starting modestly with moving 25 terabytes of data into the cloud, but this supports the Pentagon's computing direction of scalability, platform anywhere, high flexibility, instant rapid stand-up, that sort of thing, all for a military mission in which success is riding on the ability to harness and handle big data in an agile fashion.
Wow, so you got this Internet of Things at scale on steroids collecting this cloud computing processing, and it sounds like a little bit of artificial intelligence there, making some good decisions. Tom, how about at the Army? Give us an example of progress being made at the Army. I'm sure that you guys are collecting an incredible amount of data there.
So, yeah, we have a highly diverse organization with different pockets that are working in this area. And I'll just highlight some that have actually been highlighted here before, but we're working right now on this thing called the Army Leader Dashboard, which is actually an attempt by the Chief of Staff of the Army to free the data in the Army. What that means is take all the existing data sets that we have and make them accessible and available. And then once we do that, then we're going to be working predominantly on integrating the data and then putting analytics on top of that data and being able to mine that data. Now, the data sets we're talking about, we have about 1,200 authoritative data sources across our 6,000 to 8,000 different systems that we're talking inside the Army. And that could be sensor data from aircraft, from vehicles, whether it's maintenance data or whether it's like for the helicopter fleet, we get a lot of vibration data, and that allows us to, when we analyze that, allows us to make decisions on whether or not, there's some issue with the rotors or the bearings are going or things like this, all the way to the ERP systems where we're doing a lot of analysis, predictive analysis for supply chain management, right? And so we had an example early in the most recent incursions that we have in Iraq and Afghanistan, where we found out that we were blowing transmissions for our MRAPs frequently, and we couldn't figure out why. And it turns out there was a shortage of the seals between the transmission and the engine, and because they were replacing the transmissions with the old seals, it was causing leakages and causing the machines to fail at an earlier rate. And so that was a retrospective analysis that we did on the data. So that was the kind of the example of how we can now take that data and do some forward analysis, saying, hey, if we have a mismatch in critical parts where the transmission, which is a $500,000 unit, and a seal, which is $160, is the limiting factor to the maintenance of a vehicle, we need to be a little bit more proactive about managing our inventory, if you want to look at it that way.
This AI type stuff doing these, analysis and, predictive analysis, which is interesting. Dave, how about at Hitachi? I'm sure that you guys see a lot of, activity going on across the various agencies that you're dealing with.
No, absolutely.
Give us an example of some progress that's being made out there in the community.
One of the programs that I personally think is very interesting is with the NASA program at Johnson Space Center to support the International Space Station. Something that's been in the news lately is that space station will reach end of life at some point. And so I think NASA has been leaning forward to try and collect all the data it can from the space station to try and determine how and if they can extend it a few more years. Just a few more years of that up in space would certainly provide a benefit. And so you can think about all the data streaming off the space station, and being able to look at that in a single place certainly has value for the country and for NASA.
Yeah. Andy, just thinking about all the data that's being transmitted is mind-blowing to me in regards to what you're doing over there at NGA. But give us an example of the progress that's being made in NGA in regards to big data and how you're using that and processing it and analyzing it.
Sure. One of the efforts we have underway that our director, Robert Cardillo, has talked about is what we call AAA. In the sense of we bring in millions of images, 12 million, some number, huge number of images every year, gathered from satellites, reconnaissance, different things like that. Our job is we have folks who need to look at those images and figure out what's in them, right? So in the old day, what people used to do is look at each one and figure out What is that thing? Is that important? How do we provide that information to a decision maker? Whether it's, a soldier or a Marine or the president, whole spectrum of people, disaster response, things like that. 12 million images, you can't do that, one at a time by that process. So what we have is some efforts underway that we call AAA, which is automate, figure out how do we bring in those images in a very quick, expeditious way. How do we then use AI that's been trained by our analysts themselves to figure out this is a boat, this is a that, fill in the blank, those sorts of things. And then how do we then augment that information that's in that data or in that image itself, tagged with all those information. So our folks, our analysts, can literally then not have to look at millions and millions of images, but those really rare, unique cases where we don't know exactly. So the value for them is like, it takes from this tremendous volume of imagery that's coming in down to what are those key bits where they can really draw on their expertise, if they're about a certain geopolitical region, things like that, certain topic space, can really focus on that to make more informed decisions. So going from that massive 12 million images down to what is that handful of really key images that we need to know to impact a decision that's going to be made today or tomorrow and into the future?
Really narrow it down so that the analysts can use their time wisely, right, and focus on what matters. Henry, how about at Hortonworks? Tell us a little bit about some progress that you see being made across the community when you're working with the various agencies.
Sure. So everything on this panel was spot on. Everything from IT modernization to how do we take many different data sources that are stored in data silos and break them down so that we can have better access to them in the Army, to what I think is interesting along the lines of what Andy was discussing is how do we apply that same model where I don't have to have eyes on to every single item from a cybersecurity perspective as well. So from a big data side, Hortonworks has seen a larger target set that we see when we converge the data, but then how do we effectively use predictive analytics and machine learning to look for anomalous events so that I can start taking cybersecurity and do a more proactive approach to identifying targets that may never have been seen before because we know what looks normal. And I think that's a really big advancement that's happening in the community right now.
Yeah, I think the ability with all this technology to sift through this now and get it down to fine-grained and be able to focus your attention on it is a big deal, right? Not just the collection of it. It seems like the collection and the transmission is almost table stakes now. It's all about the processing and the ability to focus on it. So let's talk about some specific examples, maybe at the Army. Tom, I'll ask you. If you could just give us one specific example of where you're using this big data that's making a big difference in the Army.
Yeah. Well, so I already mentioned the logistics and supply chain management. The biggest area we're trying to, and I want to caveat trying to, right, is free the data and use it for readiness. It is really determining, are we prepared to engage in activities, whatever those activities might be, whether it's some sort of kinetic activity or otherwise, right? And so pulling together, the Chief of Staff of the Army always does this example where he pulls out his iPhone and he asks Siri, how many tanks does the Army have? And shockingly, it's within 10%, right?
I wonder what would happen if I asked Siri.
Yeah, it's a great question. But it's not really about how many tanks we have, right? It's like, do we have the right tanks in the right place with the personnel to operate them, all of the equipment to repair them, and the appropriate logistics and supply chain management around that, right? So that's actually where we're making a big push right now to stitch together. And the topic of data integration, people kind of gloss over this, right? When you're saddled with IT systems that were built in the 80s, maybe 70s in some cases, right? These systems were not designed to be interoperable in any manner, fashion, or form, right? So what we're seeing is our challenge is baselining just the most mundane information in the system, simple things like, what are all the commands in the U.S. Army, right? There is no, we know what they are, right? Because we have this thing called the Army Org Server that tells us, right? But there's no database that someone can go to and just look up, what is the actual official U.S. Army position on what Forces Command is called, right? Something that simple really causes an extrapolation and an explosion in being able to integrate information. So if you want to know where are all my soldiers and how are they trained, and but you don't know authoritatively what unit they're assigned to, it becomes a huge problem, right? And then do you trust that data? What is the veracity of that data? What is the quality of that data? And you know, it's I always say they're dirty words from the 80s, but controlled vocabularies and master data management, right, is something that everyone talked about way back in the big data warehouse days, right? But it's legit, right? You got to do it. That's kind of 101 before you can get to any analytics. And I know big data and cloud and you know, AI are like the buzzwords right now, but without some of that fundamental data work and the integration and the fusing of the data, you're not going to be able to get to that higher level analytics. And so that's where we're seeing the biggest bang for the buck right now, is really cleaning up our infrastructure to make it cloud ready, to allow us to, you know, we're not a big fan of kind of picking up things and moving them necessarily, although we have to do it on occasion. We'd like to modernize and then move, right? And that's the kind of the goal to maximize our bang for our buck there.
So cleaning up the data so that you can really get the superior use out of it.
Right.
Alan, how about at Teradata? Can you give us a specific example of where you saw a major increase, a major plus up in the use of a big data type of application?
Yeah, Luke, at CMS, Centers for Medicare and Medicaid Services, they've got an enterprise data warehouse, an analytical ecosystem called the Integrated Data Repository, which is running north of a petabyte of data right now. And it's helped detect and recover more than $10 billion of fraud, waste, and abuse just in the last few years alone. It's actually saved lives as well. And one story in particular stands out. There's a former Michigan oncologist who's now spending 45 years in federal prison for healthcare fraud.
Wow.
For exploiting his own cancer patients. He intentionally prescribed more than 9,000 unnecessary treatments to over 550 patients so he could bill more than $35 million in bogus insurance claims, much of it to Medicare. Some of these patients didn't have cancer. Some of them were already in remission and required no further treatment. Some were terminally ill, but were kept on these frivolous treatment protocols anyway. So a whistleblower came forward on a Friday afternoon, alerted the government to this activity. Over the weekend, the IDR was utilized to collect claims data as evidence against this doctor. And on the following Tuesday, DOJ issued warrants and arrested him. So here's an instance of big data being used to stop a bad actor from injecting harmful and very toxic medications into people, many of whom didn't even need them. And we've been helping CMS for more than 10 years build and enhance the IDR with extraordinary results.
An example, but a very important one. Yeah. Jeff, how about at NASA? Can you give us an example of where you're using big data to make a big difference?
Yeah, so actually the act that's created NASA back in 1958 said that we were supposed to disseminate our results to the widest practical audience, right? So with big data, we're not only disseminating results, we're actually disseminating the data then to enable citizen scientists and people all over the world to actually leverage the big data that NASA is creating. I mentioned 4 terabytes of new data every day from our Earth science work. So in our Science Mission Directorate, we've got the Earth Observing System Data and Information System. It's a network of data centers and processing facilities that serve hundreds of thousands of users all over the world. And so I think one of the biggest things that's happening is we're enabling citizen science across the world, across the U.S., but across the world. So innovation is being enabled through the data that we're gathering. And to me, that's one of the most exciting things that's happening.
Big data, big opportunities, power to the people, so to speak. Fascinating subject, and we'll be back in just a few short moments. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com. Welcome back to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com. With me on today's show are Ed Kearns, Noaa, Jeff Seaton, NASA, Andy Brooks with the National Geospatial-Intelligence Agency, Tom Sasala with Chief Data Officer, U.S. Army, Henry Sowell, Hortonworks, Alan Ford, Teradata, and David Turner with Hitachi Vantara Federal. We were talking about program-specific big data, big opportunities, big solutions. What's going on at NGA in this area? Can you give us a specific example of a program that has been, made a big impact?
Yeah, so I can give you an example of a small one, or one that's kind of getting off the ground, so to speak. Sure. One of the teams I run at NGA is called the Data Core, and it's a core group of, there's 84, 85 of us, who are data professionals, data scientists, data analysts, things like that, helping teach our colleagues throughout the agency how to do big data, break that down from AI, machine learning, things like that, to like, I'm an imagery analyst. How do I figure out what's in my picture? How do I apply these sorts of things? One of the little projects that we're doing that's kind of a marker of the efforts that we're doing is sitting down with these analyst folks who are sitting on mountains of reports, right? PDFs, Excels, spreadsheets. We've been all through large organizations. This is how they keep that data. We've been working directly with analysts to figure out how do they pull that and extract data out of that, right? Those sorts of reports, put them in databases that then they can ask questions and queries to, then eventually get into NLP, apply all sorts of technology on top of that, but take all of that data that we've got, whether it's big data or not, it's lots and lots of data, right? That's all kind of locked away in these things, and extract it and present it in a way that then they can figure out what's there, what are those things that they've been looking at before. And for us, key with our team is how can we help surface questions or help them answer questions that they might have that they could not have otherwise done. So it's a small effort, but it's one where we start replicating that throughout the agency, and we start hitting the scale of really what's the impact of using big data to inform decision making.
Yeah, start small, go big, right? Very fascinating. How about over at Hortonworks? Henry, give us an example of a specific program that you see as making a big impact.
Sure. I think one thing that's interesting on the panel mentioned citizen science. You were just talking about research. How do you enable your organization to be able to share with the community and for them to be able to take actions on that? And so we've seen an increased adoption of open source technologies, specifically around the enterprise open source realm, that allows your organization to do incredible research, to bring out data sets, but then to be able to enable other people who may not have your resources, but still use that same open source technology to be able to do that same science. We're seeing that in the genomics space right now. So right now, we have a university that is doing cancer research, and through using Hadoop and other technologies that Hortonworks supports, we are able to enable new discoveries and markers within DNA sequences to identify things that may be signs of cancer. And then that is then feeding into smaller research organizations across the country that can use that same type of technology and those same data sets to gain new insights.
That's fascinating. I love this idea of the citizen scientist. Sort of the power of one, if you will, is fascinating. Ed, how about at Noaa? Can you give us a specific example of a program that's made a huge impact in regards to big data?
Yeah, and through this Noaa Big Data project I mentioned earlier, the goal there is to break down the barriers of the use of the data to others, and as Henry was just talking about. And so the two obstacles, one are just getting access to it and also understanding it. So just getting access to it by publishing our data into our collaborators' cloud systems, that has lowered the barrier to access, because now you don't have to move terabytes of data off of the Noaa networks onto your own computers and figure out what to do with it. You can use it in place.
Which is awesome.
Which is awesome, right? And we've seen, for example, for our GO satellite, GO16 satellite, our new satellite that's up there right now, we're already seeing on Amazon, we're seeing 10 times as much data being used on Amazon than we're putting into it. So wow. It's attracting a lot of use, but then bringing down that other obstacle of understanding our data. So we typically serve the scientific community really well, within the earth science. But if you're another kind of business or you're another kind of researcher, how do you understand our data? It's kind of tough. And so what we've seen with Google as our collaborator, as we're publishing our data into the Google systems, they're loading the data into their tools that others are using, such as BigQuery, their online relational database. And what we found is that people can come in and consume the Noaa data, understand it a lot more easily once it's out of the scientific format and it's into the formats that they're used to using. We're seeing like 100 times more use of those data when we see them actually being preloaded into tools that people are already using.
Wow, yeah, it's all of a sudden you have this sort of a commercial version of this capability that allows you to slice and dice and do all these different things, putting to good use. How about Hitachi, Dave? Can you give us a specific example of where a program is making a big difference?
So I think the big data can either be new discovery or making sure that the existing capabilities remain intact. So I think the U.S. Navy is doing a nice job of taking data to make sure that their fleet stays operational. And in the old days, they used to just go by the guidebook. but now they can bring in data for the predictive maintenance, and we've mentioned it earlier.
Yeah.
But even things like the salinity of the water, the temperature that it's encountering, up to and including the port that it's going to be going to, and whether or not those services can be performed more cost effectively in that location that it will be in soon, or should they delay maintenance a little bit because it's going to be going someplace else. So I think there they can really drive down costs while increasing reliability, which is key when you're facing some limited budgets.
Yeah, I mean, just being able to use this data to become more efficient as a Navy or as a community at large. It's just fascinating. I think that's fantastic. Well, with big data always becomes big challenges, big opportunities. We're going to shift to lessons learned. And we have several folks here that have been processing and dealing with big data on a tectonic scale, and I'm sure you've got some great lessons learned you'd like to share with the community. Alan, let's start with you at Teradata. What's your sense of some of the patterns of things that you're seeing out there that you'd like to communicate to the community as they embark in this journey?
Well, I'd say that 5 years ago, it's fair to say that agencies were in the early days of some of their big data efforts, but that's of course no longer true. The challenges since then have not only been technical, but also process related. Harnessing big data requires agility and rapid development cycles, and yesterday's waterfall IT methodologies are simply too slow and antiquated to deal with big data. So examples would be accessing new data sources has to be quick and easy, and agencies can't spend weeks or months profiling these data sources because new ones are coming online continuously. New analytical techniques have to be developed and deployed quickly. Agencies have to get used to the concept of fast failure, trying novel new analytics on big data quickly, building on the successes, and tossing aside the failures and then moving on to the next project. So often at the beginning of a big data project, streamlining the traditional processes and procedures is the first step.
Yeah, all right. So it's sort of being nimble as you embark on this journey. How about at the Army? I'm sure you've got plenty of lessons learned. So Tom, can you give us an example of some lessons learned there you'd like to share with the audience?
Sure. So there's actually a confluence of events that we're seeing, and I do this presentation, and I call it our largest problem is what is known as data mining. Right, where people are hugging their data. It's my data. You can't have the data. Right. So it's a culture of freeing the data that needs to be pervasive, and compounding that problem is actually a little bit of a funding problem for the way that the Department of Defense is funded. Right. So we are given funding lines by Congress, and then we impose funding lines upon ourselves based on programs of record. Right. And so when these programs or records are very, what I call cylinders of excellence, right, they are soup to nuts. They are funded to do everything they need to do. There is not a whole lot of incentive for a program manager of a program or record to create horizontal data integration across other programs, right? Unless, of course, that program record was set up to integrate data, right? And most of them aren't. They're weapon systems or they're business systems, ERPs, whatever. And so right now, what we're trying to drive is a culture of developing application programming interfaces and creating an environment where we can actually move from the cylinders of excellence into more of a microservices environment. And so that would be the biggest recommendation I would say for anyone who's trying to tackle this is create an environment. We mentioned the citizen scientist earlier, right? Well, you can make that possible in the scale of the Army by just freeing the information, allowing people to toy with the interfaces and rapidly integrate and fuse data by not going through the user interface, or what we see today is exporting into Excel, which is our biggest data integration platform, right? So we want people to use the tools that they have at their disposal, but also get creative with the information by being able to, do whatever they need to do with the data. And so the lesson learned there is you really gotta foster this culture of openness when it comes to data. And that is actually quite challenging, especially for an institution that's 243, I believe, years old.
Right, yeah. Let's open up the aperture and let the data free, right? Interesting. Dave, how about at Hitachi? What are you seeing there in regards to lessons learned that you'd like to share with the community?
I would say the first one is make sure that what you start with is good data. Because if the data is not good,
right,
you're gonna come to conclusions and you're gonna make decisions that are likely to be flawed. I think the other thing is to have a defined scope in mind. It will change, but nobody undertakes a big data project for its own sake. It's really a program or an initiative that folks are a problem they're trying to solve, or something they're trying to understand. Then you need to think about, once you have that information coming out of the project, what do you do with it? How do you staff it? Do you need to realign your staff to actually go address some of the discoveries that you have come up with? Because chances are it's going to require you to retool your staff and how you then react to what you've just found.
Right, as that, again, cost of curiosity goes down now that you enable this new capability to happen. Speaking of good data, I'm sure there's lots of good data at Noaa. How about some good lessons learned that you'd like to share with the community as they embark on this journey?
Yeah, and one of the things we've learned through this project, these various projects, is it's hard to scale the expertise, right? We can scale the data, we can scale the process, we can scale the systems. Got to find ways of scaling the expertise, and so. By that I mean, again, to the understanding of the data. How do you get a lot of other people to understand the data? And so we've taken different approaches. One I've already mentioned about preloading the data into tools people are using. The other thing is to actually have our experts offer their code alongside of the data. So at the same place where you're picking up the data, you're also picking up maybe a Python notebook or Jupyter notebook, and you're running with that. And we've seen that work. We've seen that recently last hurricane season. It was a very active hurricane season. But there were a couple of reporters from the Tampa Bay Tribune who picked up our satellite data and used it as a backdrop to their storyboard about how Irma moved through Florida. And when we first saw this, some people made us aware, like, wow, were these trained meteorologists? Were they able to do? No, they weren't. They're just newspaper reporters that wanted to tell the story, and they were able to use some pretty complex NOAA data to tell a beautiful story about what was happening to their state, because the Open Commons Consortium had put our data right next to the code necessary to display and animate that data. And it's a really neat thing.
Interesting. So you have the citizen scientist, you now have the citizen meteorologist using a very powerful amount of data. How about at the Geospatial Agency? Andy, I'm sure there are plenty of examples of lessons learned there.
Sure. Lessons learned at NGA, also just my industry experience from before. I'll echo just the importance of understanding the quality of the data. I would even go to the sense of, like, what data do you have? Once you start kind of shaking the trees, data starts falling out from all over the place. So it's just one of, like, just what data do we have? What's been done with it? What worked? What didn't work? What are the capabilities for us and others? What are the legal things that you can do? How do you be mindful of that? We call that in our agency stewardship. So what is the stewardship of the data, right? That's the key bit. Before we start throwing any sort of algorithm on top of it, what do we have? What can we do with it? What's been done in the past? So it's like the data one, I'll echo that. Also the people part. The big lesson is what are the things, skills, knowledge that folks need to have to be able to do this, right? This does not need to have a PhD in computer science or things like that. How do we get to the folks themselves and understand, like, these are things that you can use yourself, Python, Jupyter notebooks, things like that, to be able to do really crazy, amazing stuff that has real value and impact for the individuals there. And the cultural part, that was shared is, like, how do we get it so that people feel comfortable sharing their data, sharing what they know about their data, being, like, vulnerable to a certain sense? It's just like, how do we reveal that and bring that available to others? So the two ones are echo. The big third one that I would add is, like, for any of these sorts of efforts, and this is all the work that I've done, before we start spending big money on things or resources, really it's what's the question we're trying to ask, right? And what's the decision that we're trying to make? Cut through any of the let's use AI, let's use machine learning, whatever it is, and being like, okay, what are we trying to do? Like, what is the question, right? What's the decision? How do we make it more informed? Is it worth, value-wise, this much more to do that? And just have that conversation first and go, okay, what are the tools that we need to do that? Might be a people thing, might be a data thing, might be a technology thing. But setting the conversation about doing any of these efforts, I found has been a big lesson. Not just in NGA, but in my prior work as well.
It's a fascinating point you make about the legality, right? Now that I have the power to look at all this information and slice and dice and cut it up and analyze it in a variety of ways, do I actually have the authority to do that? Now that I'm aggregating it, and I know there's been a variety of examples of when we start aggregating this data, we turn it into a different classification of data, let's call it. Henry, how about at Hortonworks? Give us an example of what you're seeing out there in regards to some lessons learned that would be important for the community to be aware of.
Sure. Yeah, echoing everything here, it's fantastic. I think one of the next pieces to that we see in a lot of government agencies are challenges when it comes to internally developing and recreating the world. We see many budget shortfalls, projects that aren't successful because they decide to create their own platform. When what's already being developed in the open source community is allowing platforms and things that have already been created that solve many of your problems, leverage the community, leverage your industry partners that are already doing enterprise open source that are there to make you successful. We're seeing this with census that are adopting these things to help the next census to be successful, right? Rather than starting from the ground floor, realize that there's already beautiful buildings that are built and work off of them to achieve your mission.
Yeah, sort of step on that platform that's already been developed and to take it to the next level. Jeff, how about at NASA? I'm sure you've got big opportunities in regards to lessons learned that you'd like to share with the community.
Yeah, a couple things. So first of all, relative to data, data is dirty. We spend a lot of energy cleaning up the data so that we can actually leverage it, right? So, because a lot of the data sets were not designed, as others have talked about, with a common data architecture, and so we've got to actually do a lot of pre-processing before we can put that data into tools and actually leverage it. So that's the first thing. The second thing is big data projects we view as team sports. It's a team activity. So we partner folks that have expertise in data science and data analytics with our scientists and researchers and engineers, because they're not going to have the time to become experts on Hadoop or the latest tools that are out there because they've got a mission to achieve. And then we partner those groups with folks that understand the technology, the cloud side of things, or the software. So really we've seen effective projects being we can pull a team together as opposed to asking one person to go and figure it out themselves. And that's the way we're able to amplify the available resources, which for everybody are limited, right? And so team sport. And then the third thing is just do it, right? So big data tools, techniques, approaches are evolving all the time. So the only way to really make progress is to get in there and try it out. Identify some problems, some questions, figure out what data you have, figure out who the potential team members are, and go in there and make some mistakes and learn some things.
I mean, it's interesting. The data is certainly dirty in a lot of cases, but this idea of sort of crowdsourcing, if you will, the capability to approach it in sort of a unified way makes a lot of sense. Okay, we'll be right back, and we'll be talking about maybe a little bit of the most difficult challenges that you all have seen, these barriers that you're seeing in front of you that you've been able to overcome. But before we do that, we're going to take a short break. You've been listening to the Federal Executive Forum on Federal News Radio 1500 AM and federalnewsradio.com. Welcome back to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com. With me on today's show are Ed Kearns, Chief Data Officer, Noaa; Jeff Seaton, Deputy Chief Information Officer, NASA; Andy Brooks, Chief Data Scientist, National Geospatial-Agency; Tom Sasala, Director, Army Architecture Integration Chief, Data Officer, U.S. Army; Henry Sowell, Chief Information Security Officer and Technical Director, Hortonworks Federal; Alan Ford, Director, Government Systems, Teradata; and David Turner, President and CEO, Hitachi, Vantara Federal. When we were talking about lessons learned, we want to move over into challenges and talk about where we've had some challenges that we've overcome and maybe some challenges that we're anticipating. Let's start with you, Alan, at Teradata. Where are you seeing some challenges out there on the forefront that have been overcome or perhaps that you're seeing in front of us?
Well, Luke, it's no longer about the big data itself. It's about the complex analytics that can be performed on the data. It's about not moving the data around to a particular platform that has specialized analytics, because with the extreme volumes we're seeing now, it's impossible to do that. It is about creating an ecosystem for that data so it can be kept in one place and bring together formerly completely unrelated analytical techniques like machine learning, neural networks, natural language processing, fuzzy systems, graph engines, and traditional SQL and run them side by side or even within each other. And that's what we've got to do going forward, is move off of the traditional paradigm of propagating data all over the data center and between data centers, and instead move the data once from source to final resting place, and have that resting place be the complete analytical
Put it
ecosystem.
where it needs to be and then start analyzing it. Jeff, how about at NASA? Tell us about maybe some barriers you see out there in front of us that you've overcome, or perhaps that you anticipate.
Yeah, I'll just focus on one. I mentioned that big data is a team sport. It can be hard to draft the right people to be on the team because the people that have expertise in data science, data analytics are in high demand. So in the government, we're not going to attract people with high salaries. So, we hopefully have challenging problems that will attract folks that want to come and take a look at what we're doing and exploring the solar system, or maybe understanding our Earth better. But really getting the talent to come to the federal government with the skills we need is one of the challenges that we see.
Sure. Big opportunity there, and a very unique situation at NASA. I think that's one of the reasons why you guys score so highly on your surveys from your employees, right? Noah, how about Ed? How about some challenges that you guys are seeing out there, or perhaps anticipating?
So one of the things we deal with is the trust issue, and it's really a data security issue. So right now people trust Noaa's data is coming from Noaa scientists, and they stake their reputation on the quality of that data. People get their data today largely from Noaa servers directly, and they trust the data because it came directly from Noaa. What we're asking now is we're publishing our data outside our own federal ecosystem into the wider ecosystem, is we're asking others to trust the Noaa data that's coming from Amazon or Google or IBM, right? And so how do we establish that trust? How do we establish the authenticity of that data when it no longer is residing only on a federal system? So how do we verify that copy against the gold copy we have on the federal side? So I think we're still a little bit ahead of the curve on that one, but we're looking at solutions to this to make this something that if users need to verify that this data is exactly the same as it came from the Noaa source, that they can do so.
Must be able to validate the source of that data. Very good point. Henry, how about at Hortonworks? Where do you see some challenges out there that you guys have been able to overcome?
Sure. I think some of the things that have been highlighted here, skill gaps are a huge issue that we're continuing to see. This is not an easy problem when you're coming from data quality issues to some of the underlying technologies that are helping to solve these problems. So one, again, you need to have the team approach where you work with those in the community that you can start filling some of those gaps. Some of the tool sets that are available now, that are out there that maybe lower the barrier to entry, that you can use existing skill sets within your workforce. If you have a lot of DBAs, that there are big data technologies that allow you to have SQL access, things like that, where you can start getting incredibly solid results out of your data sets by lowering that barrier to entry. I think that's one of the things that you see, and some of the things that I really like what Jeff was saying earlier, right? The just do it. You need to set up a culture that allows you to, I think it's a culture of failure. Fail fast, learn fast, and just do it. Make things happen. That is something that's really important.
Yeah, being able to iterate and just learn fast, I guess is what they like to call that, as opposed to fail fast. Andy, how about at Geospatial? Give us some challenges that you guys have encountered or anticipate.
Sure. Some of the challenges we have is, echoing what some of the others have said, and just in time-wise, I would go straight to the point of how do we take these big concepts of AI, machine learning, things like that, getting it so people who are not data savvy or data aware or data educated, like many of the table here, how do we kind of relieve anxiety behind that, right? How's this going to change my everyday job? What I do, why I'm at work, things like that. That's a big challenge, is the cultural part of making sure people understand that this is here to complement, augment your work, really help you focus and do those sorts of things. That's a key challenge. I mean, it's one of the efforts that we really do with that is, like, for my team and others at NGA, is we go straight to the level of empathy. I draw on my experience in like user-centered design and things like that from the consumer world, like at Yahoo Research, and just being, it's like, let's sit down and understand, as before we take this machine learning algorithm and throw it on your stuff, back off, don't use any of those terms. Sit down with folks. What are you trying to do? What is that decision that you're trying to make? What are you aware of? What skills do you have, right? How can we take what at NGA, we have tremendous resources to teach people how to use these sorts of tools and technologies. What is that individual mapping that this person needs right now to be able to use machine learning, things like that? How can it help in their work? So it's that challenge of awareness.
All this data,
Yeah.
and all this capability to process and analyze this data, what is it that you really want to do here? Yeah, it's fascinating. Well, we're going to wrap up with sharing a vision of the future. And we always like to ask folks to just kind of paint a picture. What does that look like in 2 to 3 years as you sort of look across the landscape? Henry, we're going to start with you at Hortonworks. Just give us a picture of what does it look like in the next couple of years from Hortonworks' perspective?
From my perspective, you've got two major issues, right? You've got things that are happening at the edge of your network that, whether it's sensors, and that is generating a huge volume of data. So you've got two problems. One, how do you make decisions at the edge, whether it's from a cybersecurity perspective, whether it's making a decision on something mission-based where you got a soldier in the field? How do you do that, and how do you do it effectively? And then how do you store all of those data so that you get incredible insights that you wouldn't have before? So I think what we're seeing is technologies that are starting to address data movement, data at the edge, and then lowering the cost for storing more of that data to do better data science.
Wow. Fantastic. Andy, how about that geospatial? What's the future look like in a couple of years?
I think the future for us is the one that, definitely my efforts, what I try and achieve, and the team itself is making sure our data shop is in good order, right? Like we have that good solid foundation. Priority over the vision is, we have our workforce, our analysts, our warfighters, people all over the world, that they have the skills and knowledge of varying degrees. They don't have PhDs in statistics and things like that, but they're armed with the tools and capabilities and the knowledge and to use these tools and technologies in their everyday work, but also have I would describe it as the attitude and aptitude to learn whatever's coming next, right? Because the tools are going to change and things like that. The fundamental part of what questions we're going to ask, how we're going to create value out of data, that's going to be the same. So the priority really is getting that data together, getting that ready to go, and then getting that workforce ready to go with whatever mission challenge is going to come our way, that we have the data, we can get the data, and we have the skills and knowledge to be able to address those challenges with the data that we have.
It's like a fully equipped data warrior. Dave, how about at Hitachi? What do you guys see as far as the future? What kind of technology do you see?
Yeah, so I definitely see the data issue becoming more of a part of the fabric of everyday life. If you think back 30 years, the IT shop was oftentimes off in the corner. And I think the data piece will become a fabric of everything that everybody does. And what that I think is going to allow us to do is break down some of the organizational barriers that exist to looking at enterprise data, because the technology problem will be solved. But it's being able to break down some of these organizational issues and making sure that this CDO role, if you will, is a part of everybody's job. And I believe that that will be the center of successful organizations as we move forward.
Interesting concept. Now the barriers, get reduced in regards to the technology that's available. It's now just the governance of the data and the use of the data. Tom, how about at the Army? What do you see over the next couple of years over the horizon?
Right. So we're really focusing on a number of areas right now, and Henry mentioned it earlier. Right, we really want to push the processing to the edge, whether it's in terms of machine learning or just the aggregation and the summary of the data and pulling the data back. It's not feasible to build one big database and put everything in it, right? It's just we don't have enough bandwidth. We have a lot of folks that are in bandwidth constrained environments or completely disconnected environments, but they are still generating a tremendous amount of data. So how do you get that data in a location where it can actually be processed, whether it's the soldier that is the sensor and you're bringing it back to the local command post and doing the processing there, and only sending the telemetry back that is required to headquarters. So really pushing that processing to the fringe, and then massively distributing the compute and analytics across that environment. The Internet of Things or the Internet of Everythings. Those are really the types of things that we're looking to come online and be useful, rather than locking all the data in one big database. We're suffering from vendor lock in many cases, right? So we really do want to create a free environment where the data can move where the data needs to go, right? And then the users have access to that data. And to Andy's point earlier, right, I personally would love to have an environment where we just know where all the data is for a change, right? And then being able to exploit it is really the primary.
Yeah, I imagine with the advent of open source, that's allowed you to sort of avoid the Army or the vendor lock-in, and it's sort of this Army, this soldier, if you will, becoming a plethora of IoT and becoming a computing center in their own right. It's fascinating. Alan, how about at Teradata? What do you see as far as looking over the horizon over the next couple of years?
Well, IoT and connected devices are expected to generate 403 zettabytes of data this year alone.
Zetta, and Zetta is, for our listening audience.
Zetta is 1,000 exabytes, which is 1 exabyte is 1,000 petabytes.
Which is an incredible amount of information.
Yeah, so, and that number has quadrupled since 2013, and it's going to continue to increase exponentially going forward. We'll soon be talking about yottabytes, which is the next metric prefix beyond zettabytes. So think about this, 90% of all data created on the planet to date was created in the last 2 years, and the majority of it by machines and devices. Tom used the word earlier, confluence. We need a confluence of big data and machine learning to occur. There's just too much data for humans to parse through and not enough human eyes available to look at even a fraction of it. So data will continue to scale, storage will continue to scale, bandwidth will even continue to scale, but humans don't scale well, and we're already behind that curve. So we need machine learning algorithms to automatically glean metadata from fast-moving, high-volume data streams, classify it, clean it up, transform it, and wrangle it to the analytical ecosystem for deeper understanding, and it's all got to be done before a human analyst first looks at it. So we need these autonomous decisioning platforms to do this for us, and that is where big data requires us to go in the future.
Andy, was talking about this, a lot of this sort of pre-processing, pre-work to get to the point where the analyst, which is where your finite resource is going to be, is available to only look at fine-grained data that's been curated, so to speak, and able to make good decisions. Jeff, how about at NASA? What do you see in regards to what the future looks like for NASA?
Yeah, so being in the CIO organization, Dave mentioned the IT shop in the corner, right? So we've really been trying to move away from that and actually create a team environment where the CIO organization is looked to as an enabler. So a few years ago, we started a big data working group that has more than 100 folks, and that is continuing to expand. So seeing that grow across the agency so that we've got a collaborative team facilitated by both the CIO but also our mission director, which is one thing. We'll be establishing an information management program to be able to address some of the challenges with information architecture, data architecture. So to see that actually mature to the point where we no longer have, we have fewer data silos. We're able to leverage that data as well as facilitate our missions being able to move data to the cloud and be able to not only store data in the cloud, but process that data in the cloud, because it's prohibitive now to be able to move and process and move. And so moving towards different architectures that enable big data to be used more effectively.
Right. Just sort of the power of that CIO community coming together and creating a sort of a framework across NASA and all those various centers that you guys have is going to be super important. Ed, how about at Noaa? Tell us what does the future look like in regards to Noaa? You guys have been at big data for a long time, and I'm sure you're not going to be exiting that community for a long time. So tell us what's the future look like in regards to Noaa. What can we expect as a citizen in regards to big data?
Yeah, what I'd love to see is to really have ubiquitous access to Noaa data, right? So right now we've got 70,000 different data sets, like I said, about 200 petabytes of it. Within our own organization, it's hard to get access to it. It's hard for others on the outside to get access to it. So what I'd love to see, and I think we're on this path, of providing multiple access points to our data so people can consume the data in place, again, not move it, but consume it in place with the tools that they need, these analytical tools that have been mentioned here today, the latest, greatest tools. I hear about it from our own scientists inside our organization. We've got 12,000 employees within Noaa that are using these data every day. They want access to the best tools that are available right now. And right now they don't necessarily have all the access to the data that they need to do a lot of these kind of mashups, big data analytics within our organization. And certainly from the outside, we hear the same thing from the outside, from U.S. industry. They understand the value that's inherent in Noaa's data, and they want to be able to extract that. And so Noaa is part of the U.S. Department of Commerce. One of our missions is to create U.S. jobs, help the U.S. economy, and we understand that Noaa has a lot of value within this data that could be extracted, and we want to maximize that extraction. We want to make sure these data are available to whether it's a small business or a big business. I like to say, things have really changed over the last couple of years. If you wanted to get into this business 20 years ago, you had to have a huge capital investment in order to buy the servers and the networks and stuff to play these big data games. But now every startup with a notebook computer and a credit card can amass the same level of resources that some of the big companies had 20 years ago. And so we want to create an environment where the Noaa data can facilitate that kind of economic growth and inspire people to come up with new ideas, create new jobs, solve some societal problems all at the same time.
It's super important, and a lot of public safety issues in regards to the data that's available at Noaa as well. Well, I want to thank all of our guests today for taking the time out of their busy schedule to join us for this program. I'd like to thank our sponsors, for without we don't have a show. I'd like to thank the good people here at Federal News Radio that make our program so successful and enjoyable. And most of all, I'd like to thank you, the listening audience out there that tune in every month. You've been listening to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com.